1. This lesson will be broken into 3 separate sections. The first one we're going to explore is just exponential functions. What are they, and how to solve some basic equations, exponential equations, when you can convert things to like bases. I'll then pause the video or stop it, have a second video that covers graphing exponential functions, and finally a third video that introduces the natural number e. Getting started. An exponential function is an equation in which the variable is in the exponent. To solve exponential functions, you need to determine a common base that can be used to express both sides of the equation. Express both sides of the equation using that common base. Now, since the bases are then the same, the exponents must be equal, so you can write an equation to show that the exponents are equal. At this point, you can solve the equation. Now, some applications of exponential functions include population growth, compound interest, and radioactive decay. Radioactive decay is used to date ancient objects found at archaeological sites. Here's an example. Number 1, and you have both of these examples in your notes. 8 is equal to 16 raised to the x. How can I rewrite 8 and 16 using a common base, meaning some number raised to a power? Well, 8 is 2 cubed, 16 is 2 to the 4th. So my common base is 2. Expressing this equation up here, using the common base, I change 8 to 2 cubed and 16 to 2 to the 4th. Then I remember my exponent laws from Algebra 1, where a base raised to a power raised to another power means I multiply those powers. So I multiply the 4 and the x to get 2 to the 4x. Now, since I have 2 cubed is equal to 2 to the 4x, that means if the bases are the same, the exponents must be the same. So now I can write it as 3 equals 4x and simply divide both sides by 4 and get 3/4 is equal to x. I've solved an equation that if I'd given it to you and just told you to solve it, most of you would have sat there and just looked at it, been very perplexed, and not had any idea where to go or how to go about it. Now that you've seen how to do it, it's actually fairly simple. Let's move on and try the second example. 6 to the 2x is equal to 1 over 216. Well, I don't expect you to know that 216 is 6 cubed. However, I look at 16 and I look at 6, and I know that 6 doesn't have any other bases. In other words, it's not 2 cubed, it's not 3 cubed, it's not 1 to anything. So I say, all right, great. Let me take 216, and when you have something like this, 216, I'm going to divide it by 6. Oh, that's 36. And I know that 36 is 6 squared, so 216 must be 6 cubed. Therefore, my common base is going to be 6. Now, the left-hand side over here is already 6 to the 2x, so I'm good. On the right-hand side, I've got 1 over 216. So remember, again from Algebra 1, when you've got a negative exponent, it means to take the reciprocal. So I can do 6 to the 2x is equal to 6 raised to the negative 3. Now I have like bases. I can set my exponents equal to one another, and dividing both sides by 2, x is equal to negative 3/2. Great. Now, one thing that you've got to be able to do is you've got to be able to recognize powers, or just like I did with the 216, test things out. So here are a few to look at. 36 to the x. 36 I can change to 6 squared. That means then that I can have 6 raised to the 2x. Okay. On the other side, this guy, he is just 6 to the 2x. Okay? Now I've got 243 to the 2x is equal to 3 to some power raised to the 2x. So the 2x and the 2x are taken care of. I need to figure out how many times I multiply 3 times itself to get 243. Well, you could do that a lot. You could do 3 times 3 is 9. You know that another 3 times 3 is 9. 9 times 9 is 81. So that's, at this point, 3 to the 4th. Then you go, okay, well, now what? Well, try multiplying this by 3. 3 times 1 is 3. 3 times 8 is 24. Ooh, look at that. So this is going to be 3 to the 5th. You could also, another way to do this is, again, do this. I could go 2, 4, 3. Realize it's divisible by 3, and I get 3 times 81. And then 81 is 9 times 9, which is 3 times 3. Another 3 times 3. Whoops, that looks like a 2. And then 1, 2, 3, 4, 5. 3 to the 5th. Okay? 64. X plus 1, x plus 1. Got it. So 64 is 8 times 8. I know that 8 is 2 cubed times 2 cubed. I know when I multiply like bases, I add the exponents. So this should be 2 to the 6th. And in fact, it is. And I can leave this as 2 to the 6th raised to the x plus 1, or I can distribute the 6 and get 2 to the 6x plus 6. Either one is fine. Bottom line, you can rewrite 64 using a smaller base. Now, there are 9 problems on your paper that you need to rewrite each side so that the base is the same. With the same bases, you can then set the exponents equal to each other and solve for the variable. Let's look at these first 3, and then I'm going to have you try the next 6 just on your own. So 25 to the x is equal to 5. Well, I can rewrite 25 as 5 squared. So then I'm going to get 5 to the 2x is equal to 5 to the 1. Now that I know that my bases are 5, my exponent is 2x, my exponent is 1, I set the exponents equal to one another, and I can solve. X is equal to 1/2. And remember when we did radicals? 25 to the 1/2 means the square root of 25, which is 5. So mentally, you can do a check. 9 and 243. Remember we figured out that 243 was 3 to the 5th. Okay, 9 doesn't go into 243 evenly. So I have to take both of these down to base 3. 3 squared to the x and 3 to the 5th. 2x is equal to 5, x is equal to 5/2. Finally, I have 7 to the x is equal to 1 over 49. Remember that this is a fraction. So if I look at the 49, 49 is 7 squared. So this then becomes 1 over 7 squared. But I don't want a fraction. So how do I do that? I have 7 to the negative 2. Okay, remember a negative does the reciprocal. And then I just set x equal to negative 2. Okay, you have these last 6 here to try. Let me see if I can do this. There we go. Now you can see my work. You've got the problems on your paper. You can see my work. Go ahead and pause the video for a few minutes while you work through these 6 problems. When you're done, unpause the video and check your answers, or we'll check them. I'll go over them. So go ahead and pause. You're back. I'm hoping that you paused it and you tried this, because if you're not trying these, pausing the video and trying them, you're just watching me. It's going to be difficult when you do your own. 4 to the x is equal to 1 over 32. While 4 does go into 32 evenly, it's not a base. So I have to take both of these down to 2. 81 and 27, base 3. 3 and 9, base 3. In this case, I only have to change one side. Now, remember, I have to distribute that too. 343 and 7. Well, since we're doing this, I would assume that 343 is 7 raised to some power. So you do 343 divided by 7, and you get 49, and voila, you got it. It's 7 cubed, and you can solve. Remember, when you raise a power to a power, you multiply those exponents. This one, similar to the very first one, just with a little bit more complicated exponents. And this last one, again, 1 over 8 is 2 to the negative 3. How did you do? I hope you got these, and it's getting simpler. Let's try just a few more. A little bit more practice, okay? And the monsters or pictures are just there for whatever, comic relief. So pause the video and check these out. Okay, you're back. Let's try this one. This was pretty easy because you already have like bases. Don't so many times, I can't even tell you how many times I give something like this first one here to students and they're really stumped, or they make it 2 cubed and 2 cubed, and then they make this whole equation much more difficult. If you already have like bases, just set the exponents equal to each other and say, thank you. 9 to the 3x is equal to 81 to the x minus 4. This one you could do 2 different ways. Sometimes we just get in our head, we see the 9 and the 81, they're not like, and then we just take everything down to 3. You can do that, okay? And a lot of students just immediately go to 3. You could also leave it as 9 to the 3x is equal to 81 is 9 squared, and then you're going to raise it to the x minus 4. Now you have 3x is equal to 2x minus, minus 8. Sorry about that. I have to distribute that. Then I subtract 2x from both sides, and x equals negative 8. Either way is fine. Again, over here, you have 8 and 8, so they are definitely like bases. No reason to drop. Here, whichever one you see first, they're equally as easy. Okay. Now, common mistake here with little old Igor. A lot of times people will make this 8 to the 2x. 8 squared is 64, not 16. Be very careful that you're thinking of exponents and not multiplying. You have to take both of these to 2. While 16 is 4 squared, 8 is not 4 to a power. Not a nice power anyway. Over here, 3 to the x equals 1 over 9. Doing both to 3. Hopefully these are just getting easier and easier and faster. All right, that ends this part of the video. So you can take a pause, go get something to drink, and then come back and we will continue on or go to the next video for graphing.